Hi, everyone. I'm excited to be here and to be talking to you today. My name is Jackie Wadhwa. I'm a lead product manager at Digital Element, and my focus is on IP intelligence insights and how they can be applied across fraud mitigation, risk assessment, and cybersecurity use cases. Today, I want to talk about something that happens after every fraud case your team closes and what most programs are leaving on the table when they do. The subtitle basically says it all. We're looking at turning fraud investigations into predictive intelligence. So with that, let me tell you a little bit more about Digital Element before we fully get into it. So Digital Element, or DE, as you might hear me refer to us, has been in the IP intelligence business for over 25 years. We are a pioneer in this space. We have over 50 patents, all focused on one thing: turning IP addresses into usable signals. Our customers include large enterprises across fintech, media, e-commerce, cybersecurity, and risk mitigation platforms. Organizations that process billions of online transactions and need IP geolocation signals to know how to treat their visitors and those transactions. And just thinking about the scale of that coverage, roughly 4 million unique locations mapped globally, over 500 VPN and proxy provider insights covered, over 1 billion device-derived data points. And on top of the 500 VPN and proxy providers, we do also have over 55 million residential proxy IPs flagged. So under the continuous product advancement section right there, you'll see IP forensics listed. That's our newest capability, and it's what really today is all about. It's what I'll be talking through. It takes all of these signals that I just went through really quickly and makes them queryable historically at any point in time. So let's go ahead and get into it. So I really want to start with a question. How does your team measure a good fraud detection program? So when you think about it and when you present to leadership, what does good look like? Is it cases resolved? Is it losses prevented? Is it the fraud rate is down quarter over quarter? The numbers on the slide show the scale of what we're all really working against. 80 billion in insurance fraud, 60 billion in finance sector losses, over $1 trillion in total cybercrime cost annually. These are niche problems, and they're unfortunately not going away. Most fraud teams report on cases resolved and losses prevented. That's necessary. That 100% should not ever go away. But neither tells you whether your program is getting smarter. And that's the gap we're going to be addressing today. So when you think about it, every closed case is a forensic asset we're throwing away. So here's what typically happens when a fraud case closes. The alert fires, an analyst investigates, a case is built, the case closes, and then the evidence is archived. So steps 1 through 4, your team did the job, right? The account was remediated, the loss was recorded, they did their job. Step 5 is where the real cost hides. The IP address, the geolocation, the number of observed devices associated with that IP address, the proxy data associated with that IP address, it all goes cold. And here's the problem. The same infrastructure that hit you today will hit someone else tomorrow. And it will probably hit you again next quarter under a slightly different guise, looking brand new to your current model. Every closed case is a forensic asset. Most programs really treat that like a closed ticket. So let's look at this from event-driven and moving to intelligence-driven. So most fraud programs are stuck in columns 1 or 2, and they usually don't even realize it. So reactive is where most teams live. Close the case, move on, rules gets tuned by hand when something breaks. Then there's investigative. It's progress. Cases produce real artifacts, but the intelligence stays in the case file. It never makes it maybe back into the detection piece. And then there's predictive. Predictive is where closed cases actually train future ones. The infrastructure history feeds the model, the rule, and the alert. The gap between column 2 and 3 isn't a technology gap at all. It's a workflow gap. So what I'll be talking about today is really operationalizing the third column, and specifically about the IP infrastructure data that makes it possible. So let's talk about the most underleveraged forensic signal you probably already have today. Okay, so the attacker can fake an identity, they can spoof a device and manufacture behavior, but they can't fake the network path the traffic took to reach you. That's the signal most case files reduce to a single string. IP level forensics gives you 4 dimensions that identity and device data simply do not. So, for example, where it actually originated, where that crime actually originated from, the location down to postal code, was it +4 in the US, for example? Was it hiding behind an anonymized service, a named VPN provider, a proxy provider, a residential proxy? Was it coming through a certain protocol that you might deem higher risk? And also the observed device activity around that IP address. And what network it sat behind. The ISP, the ASN, maybe looking even at the connection type. Was it coming from a mobile connection? Was it coming from a NAT or a fixed connection such as a wired or Wi-Fi connection? And then looking at how it's behaved over time. So in the last 24 months of history, and it's not about today's snapshot, where that IP address and all the signals are today. So if you look at the blue box, the blue table on the right, every row has very rich data, right? That's data that you need. It should not go away. But that last one, it's a single string. It's one moment in time. And that last line is the gap. That's the IP address. So based on that, think about the current state an IP address is. When you think about the current state, where that IP address is, it's more like a photo. But you really need the film, right? And so traditional IP tools tell you what an IP address looks like right now, today. Today's geolocation, today's proxy flag, but there's no memory of yesterday, no memory of last week, or even a year ago. They cannot answer the question that matters most in the fraud investigation. Was that IP address a proxy 3 months ago when the fraud actually happened? Did it have 300 plus devices tied to it? Was it observed to be connected from 5 different countries? Historical IP forensics gives you the film, where this IP has been and what it was doing. Geolocation movement across the last 24 months. When anonymization was active and by which provider at that point in time. So behavioral patterns, timings, regional concentration, these are all play a part in understanding the whole story, the whole film of that IP address. So fraud surfaces, I think we all know this, fraud surfaces weeks or months after it happens. By the time investigators are looking, the IP's current state tells them nothing about the state it was in when the crime occurred. So let's talk about 4 patterns you can see typically in your rearview mirror, right? So these 4 patterns have one thing in common. None of them are visible in a current state query. You only see them when you look back. So there's infrastructure recurrence. The IP rotates, the proxy provider doesn't. Same upstream tradecraft, different accounts, all 6 months apart. That's ATO, an account takeover at scale example. Geotemporal anomalies, geolocation drifting across 3 countries in 90 days while showing residential proxy characteristics. Real users don't move like that, but guess what? Fraud does. Fraud rings do. And then anonymization timing. So what if a anonymizing proxy was only used at signup, at payment, at the chargeback, never in between? The infrastructure is betraying that workflow. And then looking at ASN, ISP, behavioral clusters. So stop thinking about IPs in isolation, right? Entire ASNs can be fraud correlated historically. That's your indicator of compromise, or the IOC, not just the individual IP address. So really what I want you to take away from this slide is if your team is reviewing cases one IP address at a time, you're really reading individual words instead of a full sentence. I want to emphasize this slide and spend time through it because this is basically, we're going to walk through a scenario where IP historical insights and lookups can make a huge difference. So the scenario is a fintech company closes a $340,000 account takeover investigation. There were 47 victims, 112 IPs logged. The case is closed. 6 weeks later, someone runs a historical look back, and here's what they find. Out of the 112 IPs, 73 were residential proxies during that attack window. Only 19 are flagged as proxies today, right? That means 54 IPs looked up cleanly by the time anyone checked. current state tools would have missed more than half of the infrastructure, just completely gone, completely missed. When you cluster by proxy attribution historically, 41 of those IPs trace back to the same residential proxy service. Six ISPs account for 80% of that traffic. This wasn't 47 random attacks on 47 accounts. It was one actor, one campaign. And that signal for that point in time only exists in the historical data. Now, looking at this further, you pull the full IP footprint of that proxy service across the attack window, including IPs the attacker hasn't used against you yet. You score them all for future scrutiny, right? That's how it learns. You started with 112 known bad IPs. You ended up with over 8,400 preemptive risk signals potentially. That's the difference between closing a case and learning from one. So most teams already have everything they need to do this, right? What they're missing is the step that connects case closure to future detection. So we'll talk about this in the 4 steps. And there's 4 steps here talking about the closed case feedback loop. And here's what makes each one matter. Capturing is the part that breaks in most programs, really. An IP artifact exists. The IP address, you can capture that IP address, but nobody's systematically pulling them out, really looking into it. That has to be a built-in step, not an afterthought. Include that IP address in that case profile. Enriching is where IP forensics comes in, not querying what that IP looks like today, but reconstructing what that network actually looked like at the time of that incident. And then correlate is where that value compounds. Patterns that are invisible in a single case become obvious when you cluster across, say, 50. And then you act. Act is the payoff. Enriched signals, feeding models, and alert tuning automatically so that the next attempt against that infrastructure scores higher before a human ever sees it. Really, the bottom line, the text on the bottom here really says it all. Like, each closed case strengthens the model that catches the next one. That's really the whole loop process in one sentence. So what is IP forensics? This is the product that makes everything I've described possible so far. So it's over 24 months of queryable IP history, geolocation insights, proxy and VPN context, behavioral signals at any point in time over the last 24 months. These bullets on the left really are some of the high-level and main use cases. So identifying patterns that real-time data can't surface, activity reconstruction at the timestamp of the incident, historically grounded features for risk modeling, and point-in-time evidence for cybercrime investigations. What makes it different is what's on the right, and that is really our bread and butter from DE is IP forensics isn't pulling from third-party data feed. It's drawing from our own stack. NetAcuity for precision geolocation, IP characteristics from our first-party device-derived behavioral context, and Notify, which is our VPN and proxy attribution database. All of it historical, all of it available in a single query for IP historic lookups. So this combination, the 3 proprietary data sources that I just talked about, are delivered historically. It's what produces the signal depth, the walkthrough on the last slide that I went through. That's what powered that. So let's talk about where historical IP lookups can show up in your own stack. There are 3 main places the data plugs in. None require re-architecting anything. So that should hopefully be good news to most of you. So risk models, you're not rebuilding anything. You're adding historical IP signals as features to what already exists. Prior fraud events on the ASN, days since the last anonymization, geo drifting, location drifting, the precision lips without touching your labels. Authentication and onboarding. So a residential IP address that was known proxy 4 months ago is a different risk than one that maybe never was at all. Today's snapshot doesn't tell you that, but the 24-month historic lookup does. And then SOC enrichment. When a tier 1 analyst opens an alert, the dossier already answers, what was this IP doing the last time we saw fraud from this ASN, for example? That context changes the escalation decision before they've even had time to really have to dig through anything. So it's the same data layer, 3 different consumers, and none of it require replacing what you already have. And then really look at this as not just a fraud team play, right? This is cross-functional. So look at the 6 functions on the slide. Most of them only talk to each other maybe when something has gone wrong. Historical IP intelligence gives them a shared layer that can each use independently before the breach and not after. So fraud and risk teams use it to reconstruct what happened. Threat hunters use it to pivot from one bad IP to the full campaign infrastructure. An incident response team uses it to establish timelines and answer when an IP became anonymized, for example. Legal and compliance use it for defensible audit trails. Trust and safety use it for attribution that survives account churn. Detection engineering data analysts use it to build real training features, not just rules. So 6 different problems, same data layer, different consumers. That's how a fraud investigation outlives the case it was opened for. So let's talk about maturing the model that you have today. Where is your program today? So just looking at the slide, honestly place your program on it. Level 1 and 2 are where most teams live. IPs get logged, maybe stored, but nothing is systematically enriched or fed back into detection. Every new fraud trend starts from scratch. The jump that matters is level 2 to level 3. That's not a platform change, it's a workflow change. Closing a case now includes enriching the IP artifacts historically before the ticket closes. And then predictive, level 4, is where it becomes self-reinforcing. Closed cases automatically expand the watch list. The model updates without someone remembering to run a query. So really the leap from 3 is the highest ROI move available right now. So think about where you are in your program today and how IP intelligence, IP forensics can fit in. And as you're building the model out, improving the model out, let's talk about some pitfalls you'd want to avoid as you're doing this. And these aren't tooling problems, they're program design problems. So we'll walk through each one pretty quickly here, but we'll walk through each one. So treating IP as a single string. And this is one I really want to emphasize. Logging an IP without temporal context isn't evidence. The same address can mean 10 different things across 24 months. Over-indexing on real-time blocking. Historical intelligence isn't a replacement for real-time defenses. It's the layer underneath that makes it sharper. Ignoring NAT and CGNAT context, carrier-grade NATs. Blanket blocking a shared carrier IP is how you lose legitimate customers, and nobody wants that. Historical context is what separates a fraud ring from a busy ISP, for example. Building it in fraud and leaving the SOC out. So this is the other one I see break programs. If only one team can query the historical layer, you've solved half the problem. The patterns the SOC needs at 2 a.m. live in the same data. And then measuring the wrong thing, which nobody ever wants to do, but it happens, right? So don't just measure lookup runs, measure precision lift, measure time to attribution, measure repeat offender detection. Those are things to also think about as you're looking at the fraud program and how it's improving and becoming smarter. So 3 things to put on the board Monday. So this is kind of homework, and I guess it shouldn't be on Monday since it is Memorial Day. So sometime next week, think about this. None of this really requires any of replacing your stack. But let's talk about 3 things you can start looking at as you're thinking about how to build this model, how to improve your current workflow. So next week sometime, pull the IPs from your last 90 days of closed cases and run them against historical IP intelligence. Count how many would have failed a today only check. That number is your business case. And then pick one existing fraud score and add one historical feature. Measure the lift. That's it. One feature, one model, one proof point. And then make it a loop, make it ongoing. If the enrichment loop only runs when someone remembers to trigger it, it isn't a program. Bake it into case closure so it's automatic. And that bottom sentence here, I think that's kind of what I want to drive home. None of this requires replacing your stack. It requires changing what happens after the case closes. And before I close out here and go into the Q&A, I just want to really emphasize that every IP address that touched a fraud event has a story. Most teams close the case and walk away from it. The ones who go back, who pull the history and feed what they find into their models, those are the programs that get harder to beat over time. So IP forensics really gives you the mechanism to do that. So the case is closed, but the intelligence does not have to be. So with that, thank you for your time. I hope this was informative. I'm happy to answer any questions. We are now at the Q&A portion of our presentation. So happy to answer any questions you may have. Okay, I have a question here. How long does it actually take to run one of these lookbacks? Is this something an analyst can do mid-investigation, or is it more of a batch process? So that's a good question. Really, it's both, right? You can do a single lookup and it's fast, it's queryable. It also depends the time frame. Are you looking back 3 weeks? Or are you looking back 30 weeks? That will take a little bit more time. This is meant to be a service that you look up, not a real-time lookup. So there is latency there, but it would be maybe a second or two at the most. But when you look at that and how it fits into your enrichment workflow, so like a post-case enrichment, you can also submit a batch of IPs. So if you send us 100 IPs, 1,000 IP addresses, you'd be able to run that through certain points of time and get that information back through an API as well. So you can really have both in the end. So here's a question. How do we know if IP intelligence is reliable since IPs can be spoofed? Yes, it's true. IPs can be spoofed. So what we're telling you is the IP address, the location of that IP address, right? So when we go back in time, we can tell you if that IP address was in Florida and it might be in South Carolina today. We are giving you the most accurate assessment of where that IP address is, but we are also give you on top of that if there is evidence of some sort of anonymizing service on it. So a proxy IP address. So is it coming through a known residential proxy provider? We can see that and tell you that, so you'd be able to add that into the mix. So I hope that helps answer your question. I think we have another question. How is this different from intelligence feeds? So that's a really good question. Think about threat intel feeds. They tell you what an IP address is labeled as today. It's a verdict when you think about it. IP forensics tells you what that IP address was doing at a specific point in time. We're giving you insights into the location, the proxy provider, if there was one associated with it, how many devices were associated with it. We're basically giving you context for a point in time, not where it is currently. So that's the difference. We're not telling you that this is good or bad necessarily, where an intelligence feed is giving you that scoring. Wait a couple more minutes if there are any other questions, but these are good questions. Thank you, everybody.